Good morning, and thank you all for joining us. So this morning we have a really exciting topic to discuss, hyperscaler clean backup. As you know, with the energy transition, um, clean backup is something that we have been thinking about for a while. We have generator farms sitting at our data centers that emit NOx as well as carbon dioxide. And finding cleaner solutions to replace those generators is top of mind for us. So today we have a really exciting panel lined up for you. My name is Priya Chhiba. I'm with Google, and I lead sustainability for our data center innovation team. This team does the upfront engineering design for our data centers, and my role within this team is to incubate sustainability-related technologies that we want to introduce into our data centers. So I've been looking at this problem for a while and really interested in hearing some of the insights of these experts that I have with me. So I'm going to hand over to each one of them to introduce themselves. So first we have Gia from Schneider Electric. Gia?
Hi everyone, I'm Gia. I'm a senior systems design engineer in our CTO office for secure power. So my job is to keep an eye on trends in the data center space. I'm responsible also for our data center reference designs.
Thanks, Gia. And then we have Natalie, who is a high-performance computing expert. So Natalie?
Actually, my expertise is the intersection of high performance computing and energy efficiency, broadening to sustainability. So I chair a working group. We have about 1,200 members. It's a kind of a mini OCP, actually, but within the high performance computing community. And our mission is to try and accelerate the adoption of energy efficiency and conservation measures in high performance computing. We mostly focus on the very high-end supercomputing centers, but we also cover HPC generally, so a lot of universities, and even some industries like oil exploration and finance are some of the key sectors for this sort of domain of computing.
Great, thanks, Natalie. And then we have Otto from the NREL. Otto.
Yeah, good morning, everyone. Otto Vangeet, Principal Engineer at National Renewable Energy Lab, or NREL. It's one of 17 national labs. Lawrence Berkeley would be another one. National labs are a little bit different, one step removed from government, but primarily government-funded research. I'm a principal engineer there and focused on optimizing the energy use of data centers, meaning minimizing the energy use, and importantly, my role in OCP is on heat reuse of data centers. So I'll be talking about that tomorrow. But the game plan is sort of minimize the energy use, provide the energy from as clean a source as possible, and then hopefully reuse some of that heat.
Thank you. So, I think just for our audience here, it would be good for us to define our problem, right? So let me ask each one of you, like, what are the challenges you see with the current technology that we use for backup? Diesel generators, what's the biggest challenge? So let's start with you, Gia.
So first with the using diesel generators, we've heard from some of our customers that they're actually having some issues getting permits for diesel generators, especially in California and areas that already have low air quality. And also in cases where people want to use their diesel generators more, they may not be able to get the permit even though they're facing a lot higher occurrence of utility outages. So that's definitely one of the challenges that we're seeing.
And why do you think your customers are having permitting issues? What's causing those permitting issues?
I think just like an increased attention towards sustainability, having a cleaner environment for everyone and lower impact environmentally.
So essentially changing regulations,
Yeah,
right?
exactly.
So regulatory bodies are becoming a little bit more stringent, requiring and resulting in longer permitting times and project delays, et cetera.
Yes.
Yeah. Natalie, how about you? What do you see as some of the challenges we face with our current generator technology?
So I would like to start with a higher level question, and then I'll dive down on
Yeah,
the
sure.
generator. So in high performance computing, a lot of the supercomputing centers, they actually don't have backup on the compute nodes. They'll just have backup on storage and maybe the boot disks. And some of them just use UPSs, have no diesel generators whatsoever. So a lot of the applications have checkpoints, and they take a long time to run, but there are checkpoints along the way. So the financial cost of an outage is not maybe as severe as in some of the enterprise data centers. So I think the first question is, what kind of backup do you need? What is your mission, and what kind of backup do you need? But there are some sites like I did. So the working group the supercomputing domain is global, and my working group has people from around the world. And there is a site that does seismic analysis in Italy for ENI, which is a very large energy company in Italy. So ENI does have a very green data center, but they do have generators for 100% of their power, both in the HPC facility as well as the enterprise. And they actually don't have any problems whatsoever with their generators. They have never used them. So
So that's one of the biggest problems,
Yeah.
right? We have the generators on site.
right.
It's a capital investment, but we don't use them, right? So we have all of this generating capacity sitting on site that's maybe used once or twice a year.
Yeah.
But in general, a lot of us are not using our backup generators.
But on the other hand, there's another site in Japan, the Riken facility. It has, its power source includes generators. So they're actually using generators as part of their initial, sort of regular routine power capabilities. So they have sort of a built-in ability to have power backup in the case that their service provider gets cut off.
Yeah, hold that thought. That's a very interesting discussion, especially now seeing that our energy is transitioning to more renewable energy, more intermittent renewable energy. And so I think utilities are now looking at the data center industry to come with their own solutions, right? So before I move on to that, Otto, what do you see as the major issue with our current generator technology?
Yeah, first pollution, obviously, we just talked about that. That's pretty obvious. Cost, embodied cost and embodied energy. It takes energy just to make the generators. And then periodic testing. Everybody who has generators tests them once a week, once a month. Every time you do that, you're creating pollution and more cost. And then maybe to follow on Natalie's point, we also do, I'm a member of her group, but also do high performance computing. And I would like the industry to at least think about, as you're doing AI models, if you're training those models, it actually looks a whole lot like HPC. And I question whether you really need 100% generator backup, or if it can be much like we treat HPC, minimize your generators. And then another one for this industry where there's multiple hyperscalers, can you consider failover data centers instead of generators for each data center? So a bunch of related topics that are worth exploring.
So Gia, based on what you're seeing from your customer perspective, like what would your customers do if you told them, hey, maybe you should reconsider how much backup generating capacity you have on site?
Well, it's actually not coming from us. It's them themselves also saying like, hey, maybe we don't need generators, and they're willing to accept lower availability with just having like a 2-hour battery energy storage system or 4 hours. That's sufficient for them. And also with the having a bigger battery system, it allows them to also interact with the grid more, so they can value stack that energy resource that you can't do with diesel generator. So that's one of the arguments to move away from diesel generators. But if some people still want that insurance after 24-hour backup, and that's one of the challenges is there's not a lot of good clean alternatives just for that specific use case itself.
That's right. So I think we've uncovered a few things here, right? We have this capital asset on site that's rarely being used. We can't use it because it's a polluting, emitting source. But maybe if we had some clean generating source, like Natalie mentioned, maybe we can use it in a different application, a different use case. For instance, peak shaving, energy arbitrage. There's so many different solutions we can unlock if we thought about our backup capacity on site differently. But in order to do that, we need clean technology. Gia talked about batteries, but there's a challenge with batteries, right? They only last a certain duration of time before needing to be recharged. So I think that's one of the major challenges with finding new technologies to replace generators is how can you find something that's reliable, sustainable, that can last for longer than 24 hours and can provide that backup. So Otto, based on what you're seeing at NREL and the research you've been doing, what technologies do you think can fill all of those criteria?
Sure, I'm going to actually start with batteries because I think we underestimate the cost reduction and the improvement in battery technologies. There's massive battery factories being built around the world, including in the US. And batteries have a lot going for them. They have a very high round-trip efficiency, 95% plus. Their cycle life is really good, and they can provide alternate grid services, demand reduction, those sorts of things. So I do think batteries are important. In the other options that are out there, probably the leading one is hydrogen. Hydrogen has plenty of challenges, and we can talk about those challenges if you like. But certainly one of its benefits is it's almost pollution-free, no NOx. If it's green hydrogen, then there's no embodied CO2 also. Having said that, 99% of the world's hydrogen right now, more than that, is steam reforming of methane. So it has
Methane-based.
Yep, exactly. And then you can do a whole round trip. If you make green hydrogen, you can store it, and there's multiple ways to store it. And then you can go through a fuel cell. The whole round trip cycle is probably 35 to 40% efficient, but it can all be done on site using theoretically clean energy sources.
So if these technologies are available today, I'm guessing like all of the technologies you mentioned, hydrogen as well as batteries at a pretty high TRL, right? They've been demonstrated, they've been used, some are already in use. But what's stopping the adoption? What's challenging adoption? Because I know the DOE came up with like an adoption readiness level, right? And it seems as if we're not adopting these technologies fast enough. But so what are some of the challenges you're seeing? Gia, do you want to answer this?
Sure.
Yeah.
I think one of the challenges is if you're only strictly looking at a backup use case, it's very much TCO-wise CapEx driven, and fuel cells and hydrogen, even batteries, they just can't beat the CapEx of a diesel generator that's been around for nearly a century now. It's been cost optimized all the way. So that's one of the biggest challenges. And it's also, then people say like, well, if we do batteries, then we can value stack providing good services, energy arbitrage. And one of the challenges there is that regionally, the economic case to make for it changes based on where you are, which utility you're connected to, how much power you have. So it's not as easy as like, you can standardize, here's my data center design, backup power diesel generators, that's easy. You can't really do that with like batteries and fuel cells currently.
Otto, you had something that you wanted to share as well?
Sure. I totally agree with those points. I think similar to the battery discussion, there's a large learning curve. that goes with hydrogen as it gets adopted at a larger scale. There's hydrogen hubs. There's 7 hydrogen hubs that are coming online across the country to hopefully work on producing green hydrogen, storing it, and the whole hydrogen cycle. So
Yeah.
generation, storage, and use. So that's, as that gets better, I think you'll start to see that. And there's actually been several data center use cases of the full hydrogen cycle. Some at NREL, some at Microsoft. I'm sure there's Microsoft people in the room, and other large places in the world. And you can combine it potentially with clean energy sources, you know, solar, wind. When you have excess solar or wind, make hydrogen, store it, and then use that for clean backup or clean generation and storage, obviously.
Yeah, so what I'm hearing is while the technology is developed, the infrastructure surrounding the technology still needs a lot of work, right? So, and green hydrogen is not like readily available today, right?
Nope.
It's difficult to find, it's expensive. So, you know, there's a whole array of colors of hydrogen. So can someone explain like the different colors? I think there's blue, there's gray, there's yellow, there's green.
Sure, I'll
There's
take
white.
a start. Yeah, and maybe we can tag team it.
Yeah.
You know, green's pretty obvious. It's made from clean energy sources, solar, wind, potentially nuclear, that kind of thing. The next one is blue, I believe.
That's right.
Thanks, you can help with this too. That's where you're capturing the carbon from making it. And then gray is dirty, you know, where you're taking, and again, what most of it is right now. Natural gas, steam reforming, takes energy, and you release the carbon to the atmosphere.
Yeah, so today, as Otto mentioned, a lot of the hydrogen produced is methane-based. So methane is reformed, carbon dioxide is released into the atmosphere, and that would be gray hydrogen. If that carbon dioxide is captured, then you get blue hydrogen. And then if you manufacture hydrogen through the process of electrolysis, you get green hydrogen. So that's the purest form of hydrogen that you can get. Yellow hydrogen, I believe, is if it's paired with nuclear energy, and you're using nuclear energy to produce hydrogen. And then white hydrogen is the naturally occurring hydrogen that people are talking about these days that could be hidden in underground caverns that we would need to mine and identify and find. So yeah, there is a whole spectrum of hydrogen colors that are out there. You know, one of the things I wanted to talk about, right, is, and maybe get each one of your perspectives, is like, what does clean backup need from industry, from collaboration perspective, for us to be able to adopt, accelerate, and use clean backup? So Natalie, maybe I'll start with you on that one.
Yeah, actually, so I heard a paper recently from Idaho National Lab. They are approaching the backup question much like the Recon site. They're looking at generation on their site, and they're creating a microgrid that'll help to distribute that generation. And so I think one of the things that is sort of interesting is the concept of a microgrid. And that is a technology that I think will be very important moving forward, not just for backup, but for clean energy generally. So that's something I'd like to look more into.
That is interesting. Like, so what you're saying is we would have a microgrid at each data center that would access on-site generation capacity as well as be connected to the grid, so that it could be grid interactive too. Mm-hmm. Gia, do you have any thoughts related to that?
Yeah, so definitely, like, because a lot of data centers is essentially a microgrid with having on-site diesel generators.
That's right.
Definitely. But at Schneider Electric, we definitely have a lot of work on microgrids. And one of the things is, with all of these new emerging energy storage technologies, a lot of them actually complement one another. So that's where a microgrid comes in really handy, is that you can pair battery energy storage for your short duration backup along with a fuel cell, so you can still have that longer duration, but hey, you can still make maybe some more uses out of your battery by doing good services and all that. And also specifically now with all of the AI workloads, we're seeing very quick changes in the load profiles with AI, and diesel generators and fuel cells may not have the response time required to keep up with that new load. So that's where pairing it with the battery or super caps comes in really handy to help manage that, and also make nice with the utility so they don't see that high peak. So, and one of the partnerships that I think moving forward that data centers need to consider is partnering with utilities so they have a better idea of good capacity constraints that they might see. So that might change what kind of on-site resources they want to deploy at their data centers to help speed up deployment and things like that.
Yeah, that's a good point. Otto, do you have any thoughts related to that?
This seems like a perfect OCP topic.
Exactly. Yeah.
My thought is there ought to be an OCP focus on clean backup generation.
So let's do that, Otto.
We should.
Let's start a work stream on the data center facility, right? Because this is a problem that we need to solve. Right?
Everybody has this problem, as you
That's
can
right.
tell. And partner with national labs. We have a 20 megawatt microgrid facility, and we do megawatt scale electrolyzers and different kinds of storage and fuel cells and on and on. So we can and we're vendor neutral and all those things. So we can be part of a work stream.
Absolutely. Okay. Yeah. Let's talk and let's set up a work stream on the data center facility for that. So thank you all. Appreciate you all participating today. Hope you all enjoyed the conversation. And let's open it up to questions. Can you use the mic?
I was just wondering, actually, how much of the opportunity will come from demand reduction? So setting out guidelines of really what's necessary to back up and what's not necessary to back up. Because it sounded like you've got clients that are customers that are demanding the whole kit and caboodle, and that others have realized there's only a certain amount that's absolutely necessary. And that sounds like an easier thing to tackle than solving the whole clean energy challenge for this.
Absolutely, and I think like setting up this work stream and defining those aspects, because similar to other things, the less energy you use, the cleaner your energy becomes, right? So, if we can define, clearly what requires backup versus what doesn't require backup, and then actually reduce the amount of generation we need on site to support backup, that's a very first step.
I'm actually also very interested in workload characterization in the supercomputing domain when a supercomputing system is running a single application, and there are grand challenge applications where they get used that way. We can also see power fluctuations, right? Millisecond power fluctuations of megawatts. And that can have significant impact on power distribution systems. And I'm very interested in other workloads that might look like what we experience. So if part of what we could do in OCP would be to look at that, I think that does impact your, any kind of power system that you have, including backup. It also it impacts your distribution system generally, but it's also an area that I'm interested in, and it would help to define what are our requirements.
That's right.
Hi, Sam Calray. I'm from Sila Nanotechnologies. We're a battery startup, just to let you know where we're coming from. But my question was kind of wanting to dig a little bit more deeper into the TCO parity or imparity with regards to diesel generators and battery energy storage systems. What's the main driver when you look at kind of underneath the hood on TCO for this disparity? And how do you feel like that could be kind of more at parity in the future?
Yeah, so if you constrain it specifically to like the 24-hour backup, you can't, a 24-hour battery energy storage system is never going to be able to beat a diesel generator on CapEx, OpEx, whatever you call it. Just, it's not a good competition there. It's, the TCO then has to be brought into using your battery, using their on-site energy storage systems for other use cases, either peak shaving, demand reduction, potentially letting as a prime power source potentially, so you don't have to depend on the grid, things like that. So that's where the TCO analysis comes in. It's become a broader question.
And then, so second question there. We didn't talk a lot about renewable power generation on site. How does the value proposition change when you add that in?
So renewable power, you know, data centers are energy intensive. We use a lot of power. Having solar panels on site just doesn't make sense because you would need a lot of land to have solar panels. Wind generation is potentially okay. You can generate at capacity, but you need to be in the right region, right, to be able to generate via wind. It's also intermittent, so you never know when the wind's going to blow. So we are limited in terms of how much renewable energy we can have on site to use as a firm generating capacity.
Can I?
Yeah,
National Renewable Energy Lab, I got a comment.
go ahead.
By far, the largest generation sources currently is first solar, then wind, then batteries, if you call that a generation source. So it's actually a very good, insightful question. And I think, you know, any renewables you put in on site are better than no renewables. Now, to Priya's point, the scale becomes very large. You need tens, hundreds of acres, thousands of acres potentially to do it. But you should at least consider that. And what a lot of the hyperscalers are doing is considering that, but in the region as opposed to just on site. So I think it has to be part of the mix. But to help with the resiliency, the backup power, it would have to be on site. So thanks for letting me add to your answer.
Thanks, Otto.
And the Idaho example that I was talking about is a mini nuclear power plant with a microgrid.
That's right. Okay.
Yep. Yeah, and there's one more in there I didn't touch on, but potentially an exciting one is geothermal. Actually, you can have very high on-site generation capacities with geothermal, especially in the right part of the country or the world. Yeah, for example.
So I have a question about HVO, but I wanted to just comment on that. In Australia, where I'm from, Rowan Peck, we have a situation where there's so much solar in the grid that when you take power, you get paid to take it.
Yep.
So it's not necessarily requirement to build your own solar, be somewhere where there's already lots in the grid, and you can just arbitrage that all you like. My question about HVO was, it didn't get mentioned. A lot of engine manufacturers are testing their engines for HVO, hydrogenated vegetable oil, if people don't know that term. Does anyone want to comment on how real that opportunity is or isn't?
Yeah.
I think it's a pretty real opportunity because if I'm not mistaken, HVO can just be a drop-in replacement for diesel. So if you already have generators on site, that's an easy enough switch to help you improve your environmental metrics. So there's a lot of opportunity there, and I know there's increased production, and data centers are very interested, at least as like a transitionary fuel and things like that.
Yeah, it's something we can do immediately. It reduces our carbon dioxide emissions, but not necessarily NOx. So on-site NOx is reduced a little bit, but HVO doesn't have a big impact on NOx reduction.
So you've still got the emissions problem.
You still have the
spoke
on-site
about, yeah.
emissions challenge. But as Gia mentioned, it is a good transitionary fuel because the premise is it's biogenic sources that produce HVO. And so during plants growing, they absorb the carbon dioxide from the atmosphere and then release it back to the atmosphere, so you're creating a cycle. And that's the basis of HVO.
Yeah, and one of the things I like about it is I've already got the iron on site. So I've already got the generator sitting there.
Exactly.
And if I get rid of it, what's the embodied energy in that process
That's right.
versus keep it and find a better way to use it? Yeah. I say it's a real thing. It's happening. Like Australia, the price is ridiculous.
Yeah.
And no one's doing it.
So something you can look at is e-fuels. So that's capturing carbon dioxide and then combining it with green hydrogen to make a diesel that which has the same cyclical impact as HVO.
Thank you.
Yeah, we are actually at time. Maybe if you have a quick question, we can just take that.
In the workload characterization, how much of it is really, software having a mean time between failure and, the whole thing restarting that's generating your peak, megawatt, bursts versus if you design things in such a way where you don't actually allow for all these things to burst in peak. You don't need to necessarily start all these things at the same time type of thing. Do you see an opportunity in this space?
I'll let Natalie, if you want to go first.
I mean, there's two, it's not an easy answer, sorry. There's two things. One is during an application run, going from, some compute-intensive to an IO-intensive activity, you're going to see power fluctuations. And the other is if you have a failure and your whole machine shuts down, right? So the failures are probably a little easier to deal with. It's really hard to rewrite applications. They have anyway, it's hard to rewrite applications. It costs a lot, takes a lot, and you don't have a lot of brain power in the world today to structure all your applications for every new system that comes to the market.
Thank you very much for listening to us today. And if you want to participate, please feel free to reach out. We definitely will be starting up a clean backup work stream with an OCP. So looking forward to you all joining.
Let's thank our panelists.